Microphones generate very low-level signals, typically in the millivolt range. We use a preamp to bring that up to a usable level, called line level. If your preamp doesn't provide enough gain, the signal will be weak or noisy. Too much gain, and you risk distortion or feedback. That's why calculating the required preamp gain is a crucial part of AV system design. To calculate how much gain a preamp needs to apply, we start with the sound pressure level at the microphone, then subtract the mix reference SPL, usually 94 dB SPL. Add the microphone's sensitivity, which is usually in dBV, convert that to dBu by adding 2.2, and subtract your output level target. This formula gives you the gain needed to reach line level. Keep in mind, this formula isn't listed in the CTS-D math sheet, so you'll want to understand how to use it. This part confuses a lot of people. You might think that louder speech or a more sensitive mic should increase gain, but it's actually the opposite. The louder the input or the better the mic, the stronger the mic signal. And because we're working with negative decibel values, adding a less negative number results in less gain required. So yes, it makes sense, even if it looks backward at first. Microphone specs use dBV, but mixers and processors use dBu. To convert between them, just add 2.2. For example, minus 35 dBV becomes minus 32.8 dBu. Pro audio equipment usually expects plus 4 dBu signals. In CTS-D questions, you'll typically use either 0 dBu or 4 dBu as the target output level. For our upcoming examples, we'll use a realistic speech scenario. Imagine a person speaking normally at a lectern, with a gooseneck mic placed around 30 centimeters away. Normal speech measures around 60 dB SPL at 1 meter, 66 dB at half a meter, and about 72 dB SPL at 30 centimeters. So for our calculations, we'll use 72 dB SPL as the input level at the microphone. Let's try the formula with a real mic, the Shure MX412. Its sensitivity is minus 35 dBV. With 72 dB SPL at the mic and a 94 dB reference level, the difference is minus 22 dB. Add the converted sensitivity of minus 32.8 dBu, and subtract the output target of 0 dBu. The total gain needed is about 54.8 dB, well within the range of most pro preamps. Let's walk through the calculation using a real-world mic, the Audio-Technica U857QLU. This microphone has a sensitivity of minus 39 dBV. Subtracting 94 from our 72 dB SPL input gives minus 22. We convert the sensitivity to dBu by adding 2.2, giving us minus 36.8 dBu. The total gain required to bring the signal to 0 dBu is minus 22 plus minus 36.8, which equals minus 58.8 dB. This is within range for many professional preamps, but getting close to the upper limit. When designing AV systems, you need to think beyond specs. A less sensitive mic or a distant speaker means more gain, and more gain means higher noise risk. Choosing the right mic and placing it smartly can reduce gain needs and improve performance. It's all about designing a complete signal path, from capsule to processor. Microphone gain might seem intimidating, but it's totally manageable once you understand SPL, sensitivity, and signal levels. If you learned something today, hit subscribe and drop your gain questions in the comments, we'll tackle them together.